sticking with triangles, but we're going to go over congruent polygons today. So all of what we're talking about today applies to triangles and polygons. Okay, so congruent, as a refresher, means when two figures have the same size and shape. Okay, they have to be the same size, have to be that same shape. The symbol for congruent, again, looks like this. So in that picture below there, we have these congruent shapes. Okay, they're all the same size, they're all the same shape. However, their orientation is a little bit different, which is fine. They can still be considered congruent. In that other section, number 4 here, this image is larger than this image, so they're not the same size. And then 5 to 6, they have that different angle at the bottom there, so they wouldn't actually be the same shape either. Okay, so those ones aren't congruent to each other, even though they're all the same orientation. Yeah, it's all the easy stuff that we just went over. So 2 polygons are congruent if and only if corresponding sides are congruent and corresponding angles are congruent. Okay, so your sides from one polygon to the other have to be the same. Your angles from one polygon to the other also have to be the same. So in our examples here, this first one, we want to state which sides are congruent to each other between these 2 triangles, which angles are congruent to each other between these 2 triangles, and then we're going to write our congruent statement. So starting off with our sides, I want to look for these dash marks within my picture. So since this side has 1 and this side has 1, those 2 would be congruent to each other. So I could write out segment AB is congruent to segment HJ. Okay, when you're writing which sides are congruent, you need to label that they are segments. You need to put that congruent symbol between them. Okay, so that's one pair of sides. Moving on here, this side has 2 dashes in it. So does this side in my other triangle. So I could say segment BC is congruent to segment KJ. Last side has 3 dashes. So I could say AC is congruent to or KH. You can write HK though as well. Okay, so you can flip-flop your letters when you're writing out which sides are congruent to each other. That's fine. So instead of saying KH, you could say HK. Next, I want to move to the angles. So this time I'm going to look for those arcs within the angle. Okay, so since angle B has 1 arc, and so does angle J, those 2 would be congruent. So I can say angle B is congruent to angle J. Okay, then this angle right here, angle A, has 2, and so does angle H. So those 2 must be congruent. So we can write angle A is congruent to angle H. And then the last one has 3. So we have angle C congruent to angle K. All right. Last thing we want to do is write this congruence statement. For your congruent statement, you're stating which 2 triangles are congruent to each other. Now, for this one, your order is really important. Okay, so if I start with triangle ABC, okay, I want to see which triangle is congruent to that one. So since I started with angle A here, I need to start with its congruent angle in the other triangle. Yes. So I'm going to start with H. I went from A to B. B's congruent angle is J. And then finally to C, so to K. Okay, so for these type, your order is important. No. I want you to do 2. Okay, for this one you're given measures, but you still want to state which sides are congruent, which angles are congruent, and then write out a congruence statement. Okay, so work through that second one there. You can start doing number 3, sure. Alright, so for number 2, I wrote out which sides were congruent and which angles were congruent. Okay, so again, for your sides, you can flip-flop the letters. So instead of LK, you could have said KL. But make sure you have the correct segments congruent to each other there. For your angles, you could have first said K is congruent to M. That's fine. You don't have to do that in a specific order. But you should have all 3 of those. For your congruent statement, so some of you may have written something different than the person sitting next to you. So you could have triangle LJK is congruent to triangle QPM. So that's one way you could have wrote that one. You could have also said triangle JKL is congruent to triangle PMQ. Okay, so there's multiple ways you could do this as long as your second one goes in the correct order. So that means L has to be congruent to Q, J congruent to P, and K congruent to M. Okay, same thing here. I still have J congruent to P, K congruent to M, and L congruent to Q. Make sense?
Yes.
Okay. The one at the bottom isn't a triangle. Okay, it's a trapezoid. Has 4 sides, so it's a quadrilateral as well. But it's still the same process. So to label your sides congruent, you're going to look for those congruency markers. So since BC has 1, and XY has 1, those two would be congruent. So we can say BC is congruent to XY or YX. Moving on to the double dash marked there, I have side AB congruent to XW. 3 dashes is AD congruent to ZW. Okay, and then last one has 4 dashes, so CD congruent to YZ. Okay, so those were your 4 congruent sides. Your angles then, we have angle A congruent to angle W. Angle B congruent to angle X. Angle C congruent to angle Y. And angle D congruent to angle Z. For your congruent statement, since these are not triangles, you shouldn't put a triangle in front of it. Okay, it's not a triangle. You could put a quadrilateral, that's fine, but you don't need to. Okay, so you still want to go in the same order. So if I say A, B, C, D is congruent to W, X, Y, Z. So you could just state the letters. You don't have to put the quadrilateral in front of it. It's okay. But in this chapter, we are just going to mostly talk about triangles. So this chapter is all about triangles. So we're going to deal with triangles instead. Chapter 6, we'll get into quadrilaterals.
I think I can guess it. Back.
You can guess
Backwards.
it. It is backwards.
Wow.
So on the back, the phrase if and only if in any definition means that both the conditional and its converse are true. So your conditional is the original statement. I totally blanked on how to spell original because I forgot an I.
Me too. It's all right. I'll do it.
You know what happens?
We'll do it.
Converse means backward, okay? So I can read this definition forward and backward. Okay, that's if it says if and only if. So you take that first statement in front of if and only if, and then that second statement, and if you switch them, that statement is also true. Okay? This part right here. If 2 polygons are congruent, so we already know they're congruent. Okay, say we have 2 triangles. We already know they're congruent. Then their corresponding parts are congruent. So for triangles, we say corresponding parts of congruent triangles are congruent. Okay, that's a lot. So we just abbreviate it. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. C, P, C, T, C.
How are we supposed to remember that?
There's 3 C's.
So,
You're supposed to remember. Supposed to remember that corresponding parts. So if you have 2 parts of your triangle, just like we did on the front, we labeled those congruent. We know those triangles are congruent, so those parts also have to be congruent. Okay? So if I knew these 2 triangles were congruent, right?
Right.
I could say their corresponding parts, such as these 2 sides, are also congruent because those triangles were already congruent. Okay, that's all that this statement says. So we're going to use that in number 4 here. we have two triangles that are congruent. Okay, I can draw out those triangles. Okay.
Yep.
Now I'm going to label them. So I have one that is CAT. Now since this is the way I labeled this first one, that's how I have to label the second one.
RHS.
Yep. So angle C and angle R, A and H, T and S. So you want them to go in that same order. So I can label their corresponding parts congruent. Okay, so their sides are congruent. These angles are also congruent. Okay, and that will help me find these answers here. So I want the angle that's congruent to angle C.
Angle
Angle R is its corresponding angle. Okay, then I can go to 2. I have segment RH. Well, that corresponding side would be CA. CT is this bottom one, so RS. Angle S is angle T. I have triangle ACT. Okay, so I'm starting at A, so HRS. Last one is HS, so that would be AT. Now since I started talking about its measure, I shouldn't put a segment bar above AT. Okay, so you don't want that segment above AT. It has to look similar. Okay, this one's talking about their measures. This one is a congruency. Okay, questions on 4?
Nope.
All right. Number 5, to the right there. So in the diagram, triangle ABC is congruent to triangle DFE. When you're given something like this, you want to label those sides and those angles. Okay, so if I go from A to B to C and D to F to E, I know A is congruent to D, B is congruent to F, and C is congruent to E. Okay, they won't always be laid out this nice. Sometimes it'll turn. Okay, so you do need to pay attention to that congruent statement and label your sides accordingly.
The numbers are the same on the second.
They are, I don't know what your question is. They're congruent to the second one, yes. Okay, so now that I've labeled my 2 triangles here, I can find X and Y. Okay, so in this statement right here for this side FE, I have an X and a Y. Okay, well I need one of those in order to solve for the other. However, in angle F here, I just have a Y. And I know angle F is congruent to angle B. So I could set those two equal to each other.
Wow.
So I can set 8y minus 5 equal to 99. Add 5. So I have 8y equals 104. Divide by 8. Y is 13. So now that I know what y is, I can plug 13 in for y here. So I have 2 times 13, that's 26, plus x.
26x.
No, plus x. So I'm going to leave this side FE as 26 plus x. Now I know side FE is congruent to side BC. So I can set those two equal. So we have 26 plus x is equal to 38.4. Subtract 26. And you'll get x is 12.4. Okay, so you want to label those sides and then set which side is equal to the other side in that corresponding triangle. Okay? All right, just a couple of theorems and properties on the bottom then. So this first one here is the third angles theorem. So if two angles of one triangle are congruent to two angles of a second triangle, then the third angle must be congruent. Okay, so if I know C is congruent to K and B is congruent to J, well, if those two are congruent, if I were to subtract them from 180, I would get the same answer for A and L, so those must also be congruent. My properties at the bottom. So with triangles, we can also have a reflexive property just like we did before. So that's stating that triangle is congruent to itself. We also have the symmetric property. That's where we flip. Okay, so triangle ABC congruent to triangle EFG. I can interchange that. That is the symmetric property. The last one is the transitive property of triangle congruence. So it's just like our normal transitive property, but with triangles. So if I have triangle ABC congruent to triangle EFG, and triangle EFG congruent to triangle JKL, since these two here are congruent to the same triangle, they have to be congruent to each other. Okay, so again, just the transitive property, but with triangle congruence.
Yes. We have 15 minutes.
Oh my gosh.
So.